Hey, hi, Michael. No, I am ready. I am
Okay,
always ready. I am
great.
always ready to talk about this stuff. So, good morning to everyone, and it's my pleasure to be with all of you here today. I'm speaking to you from our MxD Learn classroom, located here in our factory at our Chicago facility. You can see a bit of the factory behind me. I do want to echo some of the remarks of some of the previous speakers by giving you an open invitation to come visit us. One of the issues with digital, whether it's students or engineers or even experts, is it's hard to see digital. It's hard to understand digital sometimes because of that. And one of the things our factory here does really well is it kind of brings it to life in the context which people can understand. So today I'm going to be talking to you a little bit about practical Industry 4.0 and why practical and what do I mean about practical. I've seen a bit of an issue developing here over the past few years. And this issue is both within manufacturers. I've seen this issue in academia, and I've seen this issue with students. And that issue is that people tend to get a little bit too focused on the technology, sometimes solely focused on technology when it comes to conversations about Industry 4.0. And then they kind of forget what the point was. And, hopefully we're going to kind of reintroduce a little bit about why Industry 4.0 came about, why it's important, and a little bit about the methodology. So here's our agenda for what I'll be talking about today. Just a brief introduction about myself. I think it's important to understand the context of how and why I talk about Industry 4.0 the way I do. We'll talk a little bit about the methodology behind Industry 4.0, and then some very practical do's and don'ts around Industry 4.0 and, of course, why it's important. So with that, Michael, next slide, please. All right, so just a little bit about background about myself. I do talk about Industry 4.0, I think a little different than many other people. And that's because I have a very practical, very hands-on background. So in terms of my experience, it spans the entire product lifecycle, everything from portfolio management to product design and development, through supply chain into manufacturing, into operations, all the way through the customer and account management, and just about everything in between. I think what's important for our conversation today, though, is that I have worked in factories. I've worked in a lot of factories. I've worked in over 200 factories in close to 20 different countries over the last 35 years. And that's really given me, I think, a different viewpoint on Industry 4.0. Again, not so much about the technology, but how that technology is applied within manufacturing environments. Next slide, please, Mike. Next slide, Michael. Thank you. So what we're going to do today is take more of a pragmatic viewpoint. And what I talk about is things that manufacturers can do right now, they can do today. Technology is only good if you can apply it. And like any tool, if you apply it wrong, you can do more harm than good. So our conversation today is not going to be about technology. We're going to take a little bit of a different viewpoint. And what you'll find, I hope, is that you'll see that technology is really more the enabler. It's not the end game. So one of my major responsibilities here at MxD as the fellow here at the Institute is to try and simplify technology, try and simplify Industry 4.0, simplify digital manufacturing, and boil it down into something that your average manufacturer can use. Next slide, please, Michael. All right, so before we dive into some of those conversations, and you've heard Liz and Michael both talk about this a little bit, but I do want to emphasize why this is important. If you look at the digital landscape today, again, it can be easy to get lost with technology, especially in the realm of larger companies. When your average person thinks about manufacturing in the US, they're thinking about these large corporations. But 98% of manufacturers in the United States are small and medium manufacturers with less than 500 employees. And as Liz, I think, had on a stat on one of her charts earlier, is that a vast majority of those, over 70% of those, are small operations, less than 20 employees. Most manufacturers in this country, over 180,000 of them are small, generally family-owned businesses. The other point here is that what I call the 80-20 rule is very much in effect even at major companies. So if you look at, say, a large company, pick any commodity. Let's say jet engines. Let's say we have a company that's manufacturing jet engines. Only about 20% of the parts in that engine they manufacture in-house. Close to 80% of that comes from their supply chain. And I think you could look at many industries, and that would be the case in many different scenarios. Supply chain is important. And if you think about it, if 98% of US manufacturers are small and medium businesses, even if you're a large company, you don't have to go down too many tiers in your supply chain to be working with these small companies. So this is important across the board, regardless of the size of company. Another challenge is there's really no universal standards in the world of digital manufacturing. Now that is changing. There's certainly many good organizations out there that are working on this, whether it's NIST or ASME and et cetera, et cetera. But even to this day, there's still not a lot of well-defined universal standards in many of the methodologies and technologies within the Industry 4.0 space. And then lastly, the rate of adoption is really wide ranging. You know, I could go talk to 10 different companies of all shapes and sizes and industries, and they'll be in 10 completely different stages in terms of their adoption of Industry 4.0 and digital manufacturing. So this is quite common. So these are really some of the challenges. So how do you get past this? And how do you have a conversation with your students, with manufacturers, on how to break through Industry 4.0 and how to break it down into a conversation that people can understand and people can relate to, which I think is the most important part. So next slide. Thank you, Michael. So a quick history lesson. I'm not going to spend too much time here. I think most of the people on the call should be familiar with a lot of the industrial revolutions and some of their history. So I'm not going to recap that in today's presentation. But there is something very important that I want to point to, and that is the timeline. Right? If you look at the first industrial revolution, you know, in the late 1700s, going to the second industrial revolution in the late 1800s, you've got about a century, right? You've got about 100 years there. Then to get from the second industrial revolution to the third, you've got about another 100 years. But then look at the fourth industrial revolution. So the fourth industrial revolution, you know, came around about 2010, 2011. When that really started. So we went from 100 years, but then we went down to 50 years. And now we're about a decade into the fourth industrial revolution, Industry 4.0 being around for about 10 years. And we're already talking about the fifth industrial revolution. There's already a lot of conversations about what Industry 5.0 is, what that looks like, and what the impacts on industry are going to be. This is important. Right? Because as you can see, the rate of change is becoming exponential. I've been to a lot of manufacturers. I've been to manufacturers today, which are still on Industry 2.0. I mean, literally, they're using century-old technology. They haven't adopted control systems. They haven't adopted automation. They don't know what Six Sigma is. That's more common than you would think. But yet, here we are approaching Industry 5.0 in the not too distant future. That's a problem. You'll find, as we discussed today, that these technologies, these methodologies, more importantly, build on each other. They're foundations for each other. You can't really go from Industry 2.0 to Industry 4.0 without understanding the steps in between. So I think that's the important takeaway here, is it's changing exponentially. We don't want manufacturers to get left behind. Next slide, please, Michael. All right, so let's start off with what is Industry 4.0. And this in itself is a major problem, because if I just hop on Google and I just go look at what is Industry 4.0, I'll get over 500 million hits on what is Industry 4.0. I can go ask 20 people, whether they're academics or whether they're from industry, and ask them, what is Industry 4.0? And it wouldn't be unusual for me to go get 20 different answers. And they might all be right, they might all be wrong, or a little bit in between. And then lastly, if you look at a lot of the written information about Industry 4.0, it was written by a lot of people who've never worked in a commercial factory before. So while there maybe is a lot of interesting theory and a lot of interesting technology, people are starting to forget a little bit about the application, which is really important. So yeah, you can see one of the problems with Industry 4.0, even a decade later, there's still a lot of ambiguity out there of exactly what it is, especially if you try and have that conversation and not talk about technology. Next slide, Michael. All right, so let's look at what is out there in terms of generally accepted definitions. So if I look at Platform Industry 4.0, which is the German consortium, which essentially coined the phrase a decade ago, they define it as intelligent networking of machines and processes, right, with the help of information and communication technology. So the emphasis there is really on the interconnection, if you will. If you look at just good old Wikipedia, they list it as the ongoing automation of traditional manufacturing and industrial practices using modern smart technology. So they're like, yeah, it's just plain old manufacturing with modern smart technology layered on top of that, whatever that is. And then lastly, one of my personal favorites is it's defined by the World Economic Forum as the advent of cyber physical systems. Now, if you put yourself in the shoes of a student, or you put yourself in the shoes of an average manufacturer, especially those 180,000 small manufacturers out there, and you give them these definitions, is this helpful to them? Is any of this actionable by your average manufacturer? Not really. And that's really one of the problems. And as academics, one of the things I really want to get you folks thinking about is how do we get past this with students so that as they go on into their manufacturing careers, their industry careers, they go in with stuff that's useful that they can apply, because a lot of the issues with these definitions are not very applicable. And if you look at all three of them, they're all different, but yet they're all technically correct. So I'm going to give you my definition of Industry 4.0 a little bit later on in the presentation, and would love to get some feedback from you folks on what you think about that. Next slide, please, Michael. All right, so we're going to do something a little different here. So you can see there's nothing to do with digital on this slide. So I want you all to like take digital and just like erase it out of your mind. Forget digital, forget Industry 4.0. And I'm going to back up to something which has been around for, wow, like 70 years now. And I really, really hope that everybody on this call knows what these are, because shockingly, there's a lot of manufacturers which don't, and that's a big problem. So on the left, the typical DMAIC cycle straight out of the Six Sigma handbook. On the right, it's known as the Deming cycle, right? The Deming cycle it's been around since the 1950s. So this stuff is not new. And, you know, you could boil this down into two simple words: continuous improvement. Now, one of the reasons why I like to start with continuous improvement, because if you look at one of the fundamental foundations of manufacturing, it's continuous improvement. It's important on so many levels. Primarily, it's important with competitiveness. And I would argue that continuous improvement is what drives competitiveness, right? If you're a commercial business, whether or not you stay alive is whether or not you continuously improve better and faster than your competition. Because if you don't stay in business very long. So continuous improvement is very important. Hopefully it's a language that, while if the manufacturers don't maybe recognize these diagrams, at least when you have a conversation about continuous improvement, it's something that resonates with them. And if it's not, then I can tell you straight up, they're not ready for Industry 4.0 yet. They're not ready for digital yet. We need to back up and have a few other lessons about things like Lean and Six Sigma before we have a digital conversation. But for the sake of this presentation, let's assume they at least know what continuous improvement is. Next slide, please, Michael. All right, so what I've done with this slide, I like to call this my digital encoder. And all I've done with this slide is on the left side, the left column, I've taken typical activities from digital manufacturing. And on the right, I've taken some of the technologies from Industry 4.0. So here I am listing technologies. But if I didn't have the column on the left, and I'm just having a technology conversation, and I'm saying, wow, how sensors are awesome and how data is awesome. But how am I structuring it in a way that I'm getting value out of that I'm applying it? So what you can see here is all I've done is just simple chart, which shows how these two are actually very well aligned and very well intertwined. For instance, one of the first steps in continuous improvement is I need to go define and measure. I need to know what the heck is going on out there in my factory floor, what's going on with my process. Well, if you think about things like sensors and you think about things like data, or how do I communicate all this? Well, then IoT. And well, how do I learn from what I'm doing? Well, analytics and machine learning as examples and so on. But what you find is that one of the important methodologies behind Industry 4.0 is this tie-in to continuous improvement. And here's the interesting thing about this chart. If you look at everything on the right-hand column, if I look at sensors, if I look at IoT, if I look at analytics, I'd even argue algorithms with machine learning and control systems, et cetera, that stuff's really not new, right? Sensors, data, IoT, analytics, algorithms, guys, this stuff's been around for like at least a couple decades, right? The internet's been around for a couple decades, more than that. So that's the whole thing, is a lot of these technologies are not really new. What's more important than the technologies themselves is how they work together and how you apply these relative to continuous improvement. Next slide, please, Mike. So one of the things that I like to say about digital manufacturing is it really puts the continuous back into continuous improvement, right? So again, technology here is not the end goal. Technology instead is an enabler to continuous improvement. And Industry 4.0 essentially builds on that foundation of continuous improvement. It's not a replacement for continuous improvement. And here's the key. So what's the big deal? Well, digital technologies and the application in a continuous improvement context, it allows manufacturers to step through continuous improvement cycles faster. And in many cases, it allows you to automate continuous improvement. What that allows you to do is it opens up use cases that you could not do before, that you could not do pre-digital, right? And let's talk about an example of that. Next slide, please, Mike. All right, so let's look through an example, and this is an example of our factory. Again, I want to encourage all of you, I believe Michael mentioned we have some great virtual tours. There's some great videos on our website. There's videos that show this particular cell that you see here on this slide in action. So if you haven't taken advantage of that, please do. And again, an open invitation to come visit us here in Chicago. So what you're seeing on this slide is this is a couple of photographs of one of our cells that manufactures a small token. On the left picture, you see the small token. It's about the size of a $50. And we give it out, as gifts to folks who visit our facility, a little souvenir, if you will. And that cell manufactures that token. So if you look at what's in the cell, a CNC machine, not new, a robot, not new, control systems, not new. If you look at any one of those individual technologies in there, it's really not new. But one of the things that MxD does really well here in our factory is how do we bring digital to life? You notice there's some monitors up there. We have a gantry with a lot of monitors. And what we show is the data streams, the information that we're gathering on the cell. This particular cell has close to 20 different data streams during manufacturing of the token. And we're not just talking about the token. So yes, it does metrology, things like thickness and weight and diameter of the token, but it takes things like ambient air temperature, humidity, coolant temperature, coolant health, vibration of the CNC machine, water temperature, cloudiness of the rinsing machine, pump currents of the water pumps, etc. And let's walk through an example of, again, back to continuous improvement and why digital makes it different. So on the right hand, all the way on the right hand side, what you see is a picture of a little washing machine. So what this machine does is the robot takes the token after it comes out of the CNC machine. When the token comes out, it's covered with coolant from the CNC process. So we need to wash that off. So the robot puts the token in that machine you see on the right, and it rinses the coolant off the token, and then it uses compressed air to dry it off. Now, in the middle of that picture, you see what looks like this dark gray tank, and that is the water tank. And what it does is it recirculates this water. So over time, what happens to water? Well, it gets dirty and it evaporates. So now let's say we have a digital sensor in this water tank, and the water tank becomes empty. And so it sends out a little signal to the cell, and it shuts down the cell. And it says, you know what? I'm empty. Somebody needs to come fill me up and replace the water. Now, that is not proactive, right? That's reactive. The cell is shut down, and it's waiting for somebody to come fill up that tank. Even though I got a digital sensor in there, so okay, it's not waiting there forever, but the sensor's saying I'm empty, and it's essentially you have downtime, right? The cell is waiting for somebody. Now let's take a different approach. Let's say that I'm looking at the air temperature, I'm looking at the humidity, I'm looking at the water temperature, I'm looking at analog water levels, I'm looking at number of cycles, and over time I can write an algorithm, essentially machine learning, which relates the changes in water level to all those different variables. Does that now allow me, rather than tell me the tank is empty, it tells me when the tank will be empty based on all this information. And if you think about that, that's just continuous improvement, right? I'm gathering all this information, I'm analyzing all this information, I'm reaching conclusions about that based on my analytics, and then I'm driving those improvements back into my control system. So it's just continuous improvement. But what this allows me to do is to predict when this tank's going to be out of water, a use case which is commonly called predictive maintenance in the Industry 4.0 circles, right? But here is the key. Could I do that manually? Could I take the temperature manually? Could I look at the humidity manually? I could, but I can't do it fast enough to have a correlation, right? I can't do it fast enough to have any meaning that's actionable. So again, what we're doing here is just continuous improvement, but because of digital, because of the near real-time nature of digital, I can do it much faster, and therefore I can apply it to use cases that were not possible doing it manually. Next slide, please, Michael. All right, digital thread. I heard the words digital thread pop up a lot in the presentations and some of the conversations so far. What is digital thread? I think a lot of people get lost in that conversation. I think a lot of people sometimes make that conversation more complicated than it needs to be. And again, there's a lot of ambiguity there. I can come up with a lot of definitions, and they're all right. But I want to give you a little bit different view of digital thread, and again, more of a practical viewpoint of digital thread, and why it's important, and how digital makes it possible. So I'm using this foundation of continuous improvement, right, as a practical methodology for applying these digital manufacturing technologies. Well, in the realm of digital thread, what does that mean? Well, if you look at your average enterprise, you have a lot of these silos. And in many companies, even today, a lot of their continuous improvement efforts, and I'm talking non-digital or even digital, they tend to be focused within these silos, right? You've got your manufacturing engineers, they're off doing their continuous improvement in the manufacturing. You get your design engineers off doing their stuff in their design. You ditto with supply chain and marketing, or really any finance, any area within the enterprise. And that can be a problem, because while you may be continuously improving that particular function, you're obviously missing on opportunity to drive that continuous improvement across the enterprise. And as anybody who's worked in Six Sigma, especially if you rewind the clock a few decades, you'll find that if you try to do that across the enterprise, it can be quite difficult. So the key here with digital thread, and the way I look at digital thread, is I look at it a little differently. Certainly, there's definitions of, one source of truth and being able to pass information up and down throughout the enterprise. And that's all true, and that's all important. But what are you trying to accomplish with that? And the way I look at that is, it's using digital technology, that promotes speed, it promotes the communication, and it promotes the flexibility needed to really now expand this continuous improvement process across the entire enterprise. That's the way I look at digital thread. It's how can I take my continuous improvement? How can I use Industry 4.0 and digital to amp that whole continuous improvement process up? But then how do I use that to enable me to do that more seamlessly across the entire enterprise? That is, to me, the important practical application of digital within a digital thread context. All right, so yeah, we're good, Michael, thank you. So on this particular slide, so how do I look at Industry 4.0? Now keep in mind, again, my background. I'm an executive from large corporations. I've worked in factories all over the world. I've done design, I've done materials, I've done manufacturing and everything in between. So I try and look at this and I say, how can I apply these technologies? And as I mentioned earlier, these technologies are really not new. So here's the way I look at it, is I look at Industry 4.0 as the convergence of digital technologies and protocols. The individual technologies by themselves are not new, and by themselves, they're not valuable. What makes them important, what makes them valuable is the convergence of these technologies. And why is that important? Because that enables high speed, in many cases, automation of continuous improvement. And think about how powerful that is. If continuous improvement is really the foundation of manufacturing competitiveness, and you can now automate that process, that's mind-blowing when you think about that for a second. If my competitiveness is relying on continuous improvement, and now I have the means of automating that process, that's huge. And then lastly, across the enterprise, and that's where your digital thread comes in. So that's the way I look at it. It's the convergence of digital technologies and protocols, which enable high-speed automation of continuous improvement across the enterprise. So I hope that resonates with you folks, and I would love to discuss that in our Q&A session if you guys have any questions about that. Next slide, Michael. All right, now we're going to talk about some misconceptions and some do's and don'ts. First of all, misconceptions, and keep in mind the context of what I've presented so far. So one, I see this all the time. Industry 4.0 forms a new foundation for manufacturing. No, not really. Continuous improvement is your foundation for manufacturing. Industry 4.0 allows you to do that faster, better, and automated. But it doesn't replace everything you've been learning in manufacturing over the last 30 years. And the next one is digital technology will fix a bad factory process. Oh my goodness. I've seen this so many times in factories where you get a factory, they don't know what Six Sigma is, they don't know what Lean is, they don't know what continuous improvement process is. They're buying all this technology and thinking that miraculously their factory is going to get better. It doesn't. They just build bad stuff faster is what happens. So yeah, don't do that. And so those are some misconceptions that I think are really important to relay not just to students, but to manufacturers as well. Next slide, please, Michael. All right, some do's and don'ts. So again, these are some practical takeaways from this that I try to show manufacturers, and I think it's equally applicable to academia and to students as well. Is one, please make sure that you understand your process and you've implemented continuous improvement. I think I've beaten that one to death, but I think you guys all understand that. But what's important here is what are you trying to fix? You don't want to go buy a bunch of technology and you end up with a hammer looking for nails. That's not very productive. So what are you trying to fix and work from there? Don't take an all or nothing approach. I see companies that feel like they've got to go all in on digital, and then they end up upside down with cash flow because they're not really fixing their problems and they're not really getting ROI. So you don't have to go all in, but then at the same time, don't be scared and not really understand and be afraid to dip your toes in the water. ROI is going to be consistent with whatever the size of the business is and what your business cadence is. So what you do here is you start off with particular use cases. You start off with one problem that you're trying to fix, and how do you apply digital technology in a continuous improvement context to go fix it? But there is also a danger with that, and that is the next one is do plan for scalability. What you don't want to end up with by doing these small use cases is end up with all these disparate systems that end up not really talking to each other. So that would kind of defeat the whole purpose of the interconnectivity of digital, as we talked about. So make sure you're planning for scalability. Make sure you have roadmaps. Make sure you have a roadmap for what my data looks like, what my communication protocols look like, what my overall technology looks like, what's a roadmap of the problems I want to fix, what's my Pareto on the problems. And then Michael alluded to it, and I know Cesar is going to talk a lot about it later on today, is don't ignore cybersecurity. And I'll give you a very real life example. So in one of my previous lives, I used to run $1 billion procurement division for a major company. And in that role, you know, if the IT systems got hacked, I mean, that's bad. Maybe I'm losing confidential information. Maybe I'm losing customer information. Certainly not a good thing. But 99% of the time, my factory is still running. I can still produce and ship product. If my OT systems get hacked, my factory shuts down. A lot of manufacturers haven't really, this hasn't sunk into a lot of manufacturers yet. They still think cyber is like an IT person's job, and they're forgetting about the OT side of the house. Don't ignore cybersecurity. The more digital tech that goes in, the more it becomes an issue. And then lastly, I think one of the most important things, not just for this conversation, but I am a firm believer in this as someone who's worked in a lot of factories, is make sure you invest in people. You have to make sure, and to me, this is really important because, again, why is this not about technology? That's because if you think about technologies, anybody can buy technology, including your competitor. And whether that competitor is down the street or whether that competitor is on the other side of the ocean, anybody can buy the same technology that you can buy. What makes the competitive difference is your people and how you apply the technology. Do you know how to install it? Do you know how to maintain it? Do you know how to apply it? Do you know how to fix it when it breaks? The people who know how to do that are the people who are going to be more successful. In my mind, people are the true competitive advantage, not the technology, and very, very important. Next slide, please, Michael. All right, and it's going to be my last slide, and then we're going to wrap it up, and I think I'm right on time. We'll leave some time for questions here. So a little bit of a historical digital lesson. So I'm obviously not a young guy. I've been around for a long time. And when I started back as a young engineer, 35 plus years ago, I walked into my cubicle and we didn't have PCs, right? I had a drafting board. I started off, having to draw my own designs. This is before solid modeling came around. Now, the particular product that I was doing back then, the cycle time, when I say cycle time, I'm talking about the development cycle time, not the product life cycle. From the time we had a concept to our first delivery to a customer, that was about a 5-year cycle. Now, if I fast forward 35 years later, that same product, the development cycle time on that product is about 6 months. 90% reduction in product development time. And one of the major reasons for that was the advent of solid modeling, digital, and simulation. What simulation allows you to do is simulation, right, allows you to do iterations, continuous improvement. It allows you to do that much, much faster. If you look at fast forward today, and let's look at manufacturing now. I've heard the word digital twin mentioned in our conversations today as well. Digital twins are mimicking a lot with simulation. If I look at simulation, I mean, simulation's not new, right? It's been around since the 1950s, 1960s, especially with NASA and the space program, once IBM mainframes came about. But back then it was like really expensive and really limited. But today I can do a pretty complicated simulation on the internet for free. What you're going to see is in the world of digital twins, you're going to see a very similar life cycle, but much faster. What you're going to see is that today, digital twins can be a bit of a heavy lift. They can be expensive to implement. But when you start to see the benefits that it brings, it's going to really, and it is, we're seeing that happen today, it is starting to transform the way manufacturers can do continuous improvement on their factory floors. So bottom line here is, if you look at that simulation analogy, companies that did not go digital did not survive. There is not a single company alive today that is not in product, that is doing product development and is not doing simulation. All of them have to do simulation. It is a key competitive advantage. And in digital twins, you'll see the same thing with manufacturing. So with that, Michael, I'm going to leave it there. I hope that this presentation is getting you to think about Industry 4.0 and digital manufacturing a little bit differently. I hope that this gives you a little bit more practical viewpoint and kind of brings us back to the why it was so important to begin with. which unfortunately I see a lot of people forgetting about. So with that, I'll pause there and welcome any questions.